All right, guys, let's start with these multiple choices, 1, 2, and 3. So we're going to go each one at a time. So we're comparing these three functions. So we have f, g, and h. And we're going to answer these questions about them. So the first one we want to do is, which function has the lowest minimum value? Okay, so in other words, we want to find the vertex. And we want to see which one has the lowest vertex, okay? So if you remember, vertex has an x value and a y value, okay, on our graph. So in essence, we want to see what is our y value, because y value controls how low or high we go. So we want to see which one has the lowest y value. All right, so g of x, if you look at g of x, that's pretty easy to see. We talked about vertex form. In g of x, we have our h and our k. And our h and k, if you remember, is actually our vertex. So real quick, the g of x vertex is essentially doing your h and k, but it has to be in vertex form, which it is, okay? So our h is 4, but remember, we have to switch the sign. So this is stuff we did before Thanksgiving break. So our h is really our x value on our vertex, so -4. And our k value is the guy adding subtracting on the outside. So that's going to be -1. So g of x vertex is -4, -1. So -1 is the lowest point here, okay? So now we got to see how it compares to these two. So let's go ahead and do this one. So this is in standard form. So for f of x vertex, we got to do some work. Okay, and these are the notes for Monday. So check those out. But I'm going to go ahead and find the vertex of this guy. Okay, it involves doing some formulas and doing some math. So to find the vertex of this guy, we got to first find the formula. This is standard form, so the formula we're going to use is -b over 2a. And if you recall, how do I get my a, b, and c? That's your a, that's your b, and that's your c. Again, this is all explained on the notes from Monday, so please watch those things. So I'm going to plug them in here. So my b is really -8. So when I plug this in, negative for the formula, and then I'm plugging in -8. Careful with that. That's a common mistake, messing up signs. And then my a value is 4. So it's going to be 2 times 4. Now let's do the math. So if you notice, my formula says x equals. So essentially, I'm finding the x coordinate of our vertex. So once I solve this, it gives me my x of my coordinate, okay? So let's look at this. Negative times -8, that's +8. 2 times 4, that's 8. So my x value is going to equal 1. So my vertex so far, I'll put it here, is 1 for my x value. Okay? Now I need to find my y value. How do I find my y value? Take x equal to 1 and plug it in for my x's in my original function. Because remember, f of x is really just y. So I could write it like this. Y equals 4. And now instead of x squared, I'm plugging in 1. So it's going to be 4 times 1. Use parentheses to plug stuff in. Minus 8 times 1 plus 10. Okay, let's do this math. We're going to do some of our in our head. 1 squared is 1. 1 times 4 is 4. -8 times 1 is -8. And then we get +10. Now let's add and subtract these. 4 minus 8, negative 4 plus 10, and that's going to give me y equal to 6. So my vertex here for function f is 1, 6. So my minimum value is positive 6. So think of a graph. Positive 6 is a lot higher than negative 1. So far, g of x has the lowest minimum value. Now we got to figure out h of x. So h of x is in what is called intercept or intercept form or factors form, okay? So we have x plus 4 x plus 2, okay? So there's actually two ways to do this guy, but I'm going to turn it into standard form so it could look something like this, and then I'm going to do this process for it, okay? But watch the video on Monday. They show you a second way of how to do this. But to turn this into standard form, I'm just going to multiply this out. So first step is let's turn this into standard form. So that's going to be x squared plus 2x. Again, to turn into standard form, we're just going to multiply it out. Plus 4x plus 8. Combine like terms, so x squared plus 6x plus 8. We'll just call this y. All right, so now we want to solve for x. So we're trying to find our vertex. We'll put that here. So my vertex, I need an x and a y. So to solve for x, we use the formula x equals negative b over 2a. And this formula works when you have standard form. So your a, b, and c in this case, a is 1, b is 6, and c is 8. So we're going to plug that into this formula. X is going to equal negative, and then plug in positive 6 here, and then 2 times 1. So let's do this math. X equals negative 6 over 2, which tells me x is going to equal to negative 3. So my vertex has an x coordinate of negative 3. Just like we did before, negative 3 is going to get plugged in here to find our y coordinate. So let's do that. Y equals, instead of x, we have negative 3 squared plus 6 times negative 3 plus 8. So negative 3 squared, negative 3 times negative 3 is positive 9. Careful with your signs. 6 times negative 3 is negative 18 plus 8. So let's do this math. 9 minus 18 is negative 9 plus 8. And that gives us y equal to negative 1. So my vertex has a negative 1. So that lowest point is negative 1. Remember, your y controls your minimum or your lowest point, okay? So if you look, h of x and g of x have the lowest minimum value. They have a negative 1 minimum value. So D is my answer here. All right. So which function has the lowest y-intercept? So number 2. What's the lowest y-intercept? Okay. How do I find that? If you recall, if I plug in 0 for x, it would give me the lowest y-intercept. So let's do that. Okay. So we're going to do this mentally. All right. The y-intercept for f of x, if I plug in 0, 0 squared, 0, 0 times 4 is 0, so this turns into 0. 8 times 0, 0. So all this is 0. What I'm left with is the y-intercept of 10. So f of x has a y. We'll put this up here. Y-intercept equal to 10 for that guy. All right, same thing here. We plug in 0 for x. So 0 plus 4. Again, we're going to do this mentally. 0 plus 4 is 4. 4 to the second power. 16. Let's do that math. So 0 plus 4 squared minus 1. So again, to find the y-intercept, plug in 0 for x. So this turns into 4 squared. 4 squared is 16. 2 times 16 is 32 minus 1. So this has a y-intercept of equal to 31. Okay, as you can see, finding the y-intercept in standard form is a lot faster than vertex form. So h of x, I'm going to plug in 0 for x. And let's do this math. So we got 0 plus 4, parentheses, 0 plus 2. Okay, that actually gives me 4 times 2. 4 times 2. So my y-intercept for this guy is 8. Who has the lowest y-intercept? So we have f of x has 10. G of x has 31. And h of x has 8. So my answer is C. Okay. Which function is the widest? So this is some stuff you have to remember from a couple weeks ago. Your a value controls how wide / thin or skinny your function is, your graph. So how do I know? If a is bigger than 1, it gets skinnier. Okay? This is all from the week before Thanksgiving. If a is less than 1, think fractions, don't think of sign. If a is less than 1, it gets wider. So which function is the widest? So we're looking for the a value. That gives me the widest. All right. So if you look at f of x, my a value, so let's label these bad boys. My a value is 4. So that's bigger than 1. So it's going to be pretty skinny, okay? Over here, my a value here, which is this guy, is 2. So that means g of x is slightly wider than f of x, because g of x is a smaller number, okay? Our a value over here is actually 1. Okay, so because of that, which one is the widest? Which one has the smaller a value? Okay, so think of it, smaller a value is the widest. The bigger the a value, the skinnier, okay? So if you look, h of x has the smallest a value, therefore this C would be my answer. Okay, I know it's a lot of information there, but that's some good exercises there to get comfortable with. It's everything we've done before, including the new stuff that you should have seen on Monday from your notes. All right, let's get into problem number 4. I'm going to do problem number 4 and let you do problem number 5 and 6 on your own. Okay, and that basically is your assignment for Tuesday. Okay, so let's look at this. Our goal here is we have standard form, A, B, C. So I'm going to label those. Here's my A value, B value, C value. When I talk about ABC, remember it's just the number. Your A is always in front of the x squared, your B is always in front of the x, and your C is the guy without the variable, including the sign, so be careful there. So to find our vertex, we need x and y value. Okay, so let's find our x value using our, this is actually called the axis of symmetry formula. It gives us, if you remember when we graph, it gives us the vertical line. I'll show you what I'm talking about when we start graphing this thing. Okay, so now let's do this math. I'm going to plug in b. So x equals negative for the formula, and then my b value is negative 8. So negative 8 all over 2 times a, which is 2. All right, so if we do this math, negative times negative 8 is positive 8. 2 times 2 is 4. 8 divided by 4, that gives me 2. So my x value is equal to 2. All right. What this also gives me is my axis of symmetry. Okay. So what does that mean? On your x, we're going to go to positive 2, and we're going to put that vertical line. Remember, the axis of symmetry cuts my parabola into 2 equal parts. So we have just found not only the x part of my vertex, but we also found that vertical line that makes my parabola symmetrical, which means the left and the right side are the same across this line. Okay, so axis of symmetry there is x equal to 2. It's always an x equal to a number equation. Now we got to find, we found our x value, we got to find our y value by plugging in the x value back into our equation. So instead of f of x, I'm going to write it as y. So y equals 2 times, instead of x, we now know x is 2, so I'm going to plug in 2 here. 2 squared minus 8 times 2 plus 4. So let's do this math. Order of operations says 2 squared is 4. So we're going to have 2 times 4. Negative 8 times 2 is negative 16. And then positive 4. Okay, so for room's sake, I'm going to just do the math here. What's 2 times 4? This gives me positive 8. So let's put positive 8 here. Okay, and now we could do adding and subtracting. So if we do adding and subtracting, 8 minus 16, that's negative 8. Negative 8 plus 4 is negative 4. So I have found my vertex. I'm going to put a dot at 2, negative 4. Okay, it better be on this line. If it's not on the line, you did something wrong. So 2, negative 4. 1, 2, 3, 4. Okay, and there's my vertex. All right, so we graphed the vertex there. Okay, now I want to graph the y-intercept. Remember, to graph the y-intercept, all we're going to do is plug in 0 for x, because our y-intercept is always 0, comma, something. So this is our x, this is our y. So we're going to plug in, just like we plugged in 2, just like this plugged in 2 and it gave us a y. We want to know what y is when we plug in 0. So we're going to take our original and plug in 0. So y equals 2 times 0 squared minus 8 times 0 plus 4. Okay, and let's do this math. It's pretty quick. Especially in standard form, it's very easy. 0 squared is 0. 0 times 2 is 0. So this turns into 0. Negative 8 times 0 is 0. So you put positive here if you want to add zeros. It really doesn't do anything. And then bring down the positive 4. So my y is equal to positive 4, which means my y-intercept is 0, 4. So I'm going to plot that point. 0, 4. Okay, and I can mirror this, right, across. So I have the left point, I could do the right point. That's what makes this axis of symmetry important. Now, I want to do a couple more points, okay, because we have to find the x-intercepts, and we're going to guess them, approximate them, but I got to do a little more accurate graph. So, if you recall, we're going to use the 1, 3, 5 pattern. So as a reminder, starting at your vertex, what this says is if I go over 1, this tells me I'm going to go up 1 because it's positive. If I go over 1 again, this tells me from that point I'm going up 3. If I go over 1 again, I go up 5, okay? But in order to use this properly, I gotta adjust it using my A value. So that means my A value gets multiplied in to get my true pattern. So here's my A value. And all we're gonna do is multiply to get my true 1, 3, 5 pattern. So 2 times 1, 2. 2 times 3, 6. 2 times 5, 10. Okay, so this is my true 1, 3, 5 pattern. So watch how this works. Again, if you are unsure about how I got this, watch the week before Thanksgiving. I explain this. Okay, it's also in all the notes. So starting at the vertex, go over 1, and then this says after I go over 1, since it's positive 2, I'm going to go up 2. Over 1, up 2, put a dot. So I went over 1, up 2. Okay. The next one says, from here, this new dot, go over 1 again, always going over to the right one, and now we're going to go up positive 6. So over 1, up 6. 1, 2, 3, 4, 5, 6. And look, we already have a dot there. So I went over 1 and up 6. 1, 2, 3, 4, 5, 6. Okay, and we're going to run out of room here, but we are now at this dot. So we would go over again, but now we're going to go up 10. Over 1 and then up 10, but we're not going to put this dot because we would run out of room. Now all we have to do is mirror it or copy it over the axis of symmetry. And now we got a more accurate graph, so I'm going to connect those. Okay, and what this is asking us, what is our x-intercept? So where does my graph touch the x line? So I'll put those in purple. And again, these are guesses because it's not perfect right here. Okay, so I think my x-intercepts, remember x-intercepts will have, we have 2 of them in this case. When you have an x-intercept, your y value is 0. So we need an x value and a y value. X value and a y value. So our y values for x-intercepts are 0. So where do you think this crosses the x-axis? I'm going to say about 0.5. Okay, so my first one is 1/2 or 0.5. Again, these are approximations based on what you have in your graph. This one, we'll say it's, it's 1, 2, 3. We'll call it 3.5. Okay, so those are my as accurate as it can, a guess of what my x-intercepts are. That's why it says approximate. Later on, we're going to talk about how do we really find these. Okay, there's math where we will actually get the exact x-intercepts. Okay, so that's what you're doing today. Go ahead and do 5 and 6. I'm going to give you the check-in code, get you out of here, and we'll call it a day.